Welcome to myprojectbazaar.com. Now we are going to discuss about the project fire detection in the buildings using image processing. Now we are going to discuss about the abstract of the process. In this process, we present an approach that involves the use of k-means clustering algorithm with the k nearest neighbor and then the efficient supervised learning algorithm that extract the patterns as well as detect the trends that are hidden in the complex data. Previously, in some other papers on object recognition and detection method, which concentrate majorly on the use of feed-forward neural network and other classifiers such as naive Bayes and decision tree alone for the modern fire detection applications. But in our proposed systems, we are concentrate in the combining of k-means with knn and then extract the other method features like color and textures in order to improve the detection rate of event detections applications. On the other hand, this process involves the steps like segmentation, feature extraction and classification. These three plays a major role in this process. In this segmentation process, the clustering is applied to clusters the fire region from the background region. Then the feature extraction is applied to extract the features from the image. Then finally, classification report will generate the report as whether the fire has occurred or not. Then finally, the process of the overall process is performed by using the accuracy, sensitivity and specificity. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The modules consist in this project as input, pre-processing, segmentation, feature extraction, classification and performance estimation. First of all, the input is taken from the dataset image. The dataset image consists of both the fire image as well as the non-fire images. So we have to get any one image from the dataset. After that, we just move on to the second stage of the process, that is the pre-processing. This pre-processing image resize alone is used to resize the image into an aspect ratios. After converting the image into an aspect ratios, we just move to the third stage of the project, that is the image segmentation. In this segmentation, you obviously know about the segmentation. Segmentation is to extract the particular data from the other unwanted data. So in this process, k-means clustering is applied to extract the fire regions from the background region. So after getting the fire region, we have to do the feature extraction. So in this feature extraction, we have two kinds of feature extraction is there. One is based on the color based feature extraction, then the another one is based on the texture based feature extraction. The color based feature extraction is applied by using the histogram algorithm, that is the histogram of oriented gradients HOG. Then the texture based feature is extracted by means of the algorithm Gabor feature extraction method. After extracting these two features are combined together to generate the test feature. Then after next to the feature extraction, we are doing the classification. In this classification, we are using the k nearest neighbor, that is the knn classification method, to classify whether the input is fire or non-fire. After doing this all, we have to find out the performance of the process. The performance of the process will be evaluated by means of the accuracy, sensitivity and specificity. These are the three parameters to justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the MATLAB 2015b and change the current directory. If you want to execute the file, just right click in the main_GUI.m and select the option run. Now the user interface was open. In that user interface, you can see the several push buttons in the right side for the controlling actions and then the several axes and tables in the left side for the display purpose. First of all, click the button input image. After clicking the button input image, you have to open the dataset folder and then we have to select the input image from the dataset. After the selection of the input image from the dataset, the corresponding image is shown in the axis 1 with the title of input image. Then we go to the next step of the process, that is the pre-processing. In this pre-processing, we have two kinds of pre-processing. Already we have discussed about the image resize and filtering. Since the image is resized into an aspect size of 256 cross 256, then the noise is removed by using the filtering method. After the pre-processing, we just move to the third stage of the project, that is the segmentation. Segmentation in the sense we have to extract the foreground from the background. This is the cluster 1 and cluster 2. So we are extracting the cluster 1 and cluster 2. So we are have to select which clusters we required. So I am selected the second clusters I am required. This is the segmented portion of the fire region. After that we have to extract the features from that fire regions. Then click the button feature extraction. Now the HOG plotter will be looking like this. Then the corresponding values of that histogram will be shown in this table. Then finally we just move to the classification step. In this classification step, it will denote whether the fire is occurred or not. If it is on fire region, means it will be shows the message box like fire was identified. After doing the classification, we just move to the final stage of the project, that is the performance estimation. In this performance estimation, we have three kinds of performance parameters, that is the accuracy, sensitivity and the specificity. So accuracy represents how much of performance we are achieved by using this classification method. Hence those values are plotted in this table and then the corresponding plots will be represented like this. Thanks for watching this video.